Welcome to today's math on organized lists. When you're doing organized lists, you have to have a game plan. It's one of the more challenging things in our math this year, just because it's so conceptual. You have to have a game plan to figure out how to do the question. And once you get started, it's pretty easy, but getting your head around it is the problem. So the first thing to understand is remembering that a favorable result is what you're looking for in terms of probability. For example, heads on a coin or the color yellow on a spinner. So an organized list is simply a list of all the possible outcomes and things that don't really work with the tree diagram. Tree diagrams and organized lists are essentially the same, except you can't really do tree diagrams with the problems that you get that you need to do with an organized list, if that makes sense. Okay, so there's multiple outcomes. It's more complex than just like picking a red card out of a deck of cards, because we know there are 52 outcomes with a deck of cards. Organized lists and tree diagrams are about figuring out how many outcomes there are. It's like getting given a deck of cards and you have to count the cards to figure out the probability, which you never, of course, have to do. But an organized list and a tree diagram essentially is like having a deck of cards but not knowing how many cards there are. So you need to figure it out. So let's go over the work that I assigned yesterday. I have 3 coins. Possible coins are a toonie, a loonie, and a quarter. What is every money total possible? Hint, start with 3 toonies. Okay. So, my advice was start with 3 toonies because that's the highest number possible. So take a look. In my first line, I went with 3 toonies, followed by, I kept 2 of the toonies the same and changed the 3rd coin to a loonie, and then I kept the 2 toonies at the start, and then I had the 3rd coin as the quarter. On the next line, you can probably figure out what I did. I changed one thing to start with. So I changed the middle coin. I still start with the toonie, I finish with the toonie, but instead of having 2 in the middle column, I've changed that to 1. So basically, I follow the same pattern as my top line. So a toonie, a loonie, and a toonie, a toonie, a loonie, a loonie, a toonie, a loonie, and a quarter. You will see a pattern. Whenever you do an organized list, if you're doing it properly, you're going to see a pattern. Okay, and then let's finish that one out. So I still start with my toonie. I always want, in my left-hand side, I want the biggest number and work from highest to smallest. So down here, you will imagine I'm going to have quarter, quarter, quarter. Okay, so toonie, quarter, toonie, toonie, quarter, loonie, toonie, quarter, quarter. You can see the pattern. The left-hand column stays the same. The middle column goes 2, 1, quarter. And my right-hand column, I've got toonies, I've got loonies, I've got quarters. But if I look this way, it's always going down. 2, 1, quarter, 2, 1, quarter, 2, 1, quarter. So there's many patterns as we do this. Let's see, let's pause it. Well, let's have the loonie as the left-hand column and see if you can do the 9 outcomes. Give it a try. So pause. Let's take it up. It should look exactly the same, with the only difference being I've got loonies in that first column instead of toonies. So pause it and try it for quarters now. There you go. So how many outcomes are there? Well, there are 9 in each kind of block, so 27 in total. Now, my question actually asks, what's the money total for each? I would then need to go in and count the money. So I would have $6 here, I would have $5 here, I would have $4.25 here. And this is the cumbersome, boring part of it. So my biggest number would be $6 and my smallest number would be 75 cents. Okay, so that's how to work with an organized list. I want you to try one. Okay, so here we go. My bike lock has three combinations, has three numbers ranging from 1 to 3. How many possibilities are there to guess that combination? So, I'm going to give you a hint. There are 3 outcomes, and there are 3 columns. It should look something like this. So give it a try and pause. So you probably went about it the same way. With my biggest number is 3, so I'm going to start with 3s. And I actually went across instead of down, so my pattern looks a bit different. Okay, so I went with my 3s, my 3 3s, my 3 2s, and my 3 1s. Then my 2 3s, my 2 2s, and my 2 1s, my 1 3s, my 1 2s, and my 1 1s. So it's basically the same, and it doesn't matter that I did it differently. This made more sense when it's not money. Every organized list might be different, and that's what makes it so difficult to teach, because it's a concept. You have to understand an organized list and then execute it, as opposed to a formula where you plug numbers in. So it makes it so challenging. Okay, you got to understand how to make that plan. Okay. At Wonderland, 4 friends sit next to each other on the slingshot ride. Tony, Bert, Luke, and Wanda want to know how many seating outcomes there might be if they sit randomly. So, I start off with the first one. I basically take the 4 names, I change it to initials, and then I keep them in that order. So Tony, Bert, Luke, Wanda. So, how I'm going to start this, I'm going to keep the first 2 the same and then just flip. So I'm going to go Tony, Bert, Wanda, and Luke. Okay, so I'm just basically on this first line, I'm going to keep Tony at the front, like that first seat all the time, and then I'm just going to change, I'm going to switch them out from there. So this is Tony with Bert second. This is Tony with Luke second. Okay, so Tony, Luke.